All right, this is the answer key for the Unit 11 practice test. So just to know, I talked about this in class, but the test is Friday, May 9th, but because of the absences due to AP testing, day 1 next week is another day that you can take the assessment. Okay, so I'll talk about this in class, but you can either take it this Friday, May 9th, or day 1 next week. Okay. All right, here we go. Let's go through the notes. So first we have trapezoid rule. So trapezoid rule is this idea where we have a function, right, and we're estimating the area by drawing those trapezoids underneath. And essentially all you need for this is the area of a trapezoid. So what is the area of a trapezoid? It is what? It's 1/2 parentheses b1 plus b2 times h. Good. So again, like when we think about the trapezoid, this is your h down below, and then b1 and b2 are at the sides. Okay. For Riemann sums, so Riemann sums are not trapezoids; they are rectangles, right? And so we have these 3 different situations. We have the left-handed ones where the left side of the rectangle is the height. We have the right-handed ones where the right side is the height, right?
Why would the height be the bottom of a trapezoid?
It's kind of like a trapezoid on its side. That's why. Over here. It's kind of confusing. So same idea here. You have to, for this it's easier because it's just, the area of a rectangle is just length times width or base times height, right? And that's pretty easy to get, right? When we talk about summation notation, we have 2 situations. We have right-handed and we have left-handed. For right-handed, you take the sum, you start at 1 and you go to n, and on the inside it's 1 over n. Hang on. Sorry, b minus a over n. Sorry, not 1 over n. b minus a over n. That's the width times f of a plus b minus a over n times I. So this is the, if I zoom in here, this is the width, right? B minus a over n, that's the width. And then we're multiplying width by the height, and the height is the output of that first term plus the width times I. Left hand is the exact same. The only change is that we switch I to be 0, and then the n to be n minus 1. But everything else is the same. It's b minus a over n. I'll pause, yeah. F of a plus b minus a over n times I. So left-handed, we start at 0. Right-handed, we start at 1. Left-handed, we go to n minus 1. Right-handed, we go to n. But this side is the exact same. We have the width here. This left side represents the width, and the right side represents the height. So the right side is saying the output of that that starting point plus the width times I. We have some problems that'll go over that in a bit. So, okay. Limits graphically. So this was where you're given some drawing, and you're told, okay, what is the limit as x approaches some number, right, of f of x. So just remember that if it says limit x approaches a with a little plus sign, that means what? If it's got that little plus, that means from the right, and if it's coming from the left, it has a little negative sign, right? This means from left. The limit does not exist if what? What happens if the limit does not exist?
If
D and E.
Mm-hmm. If the limit from the left and the limit from the right don't match. They don't high five, right? So if you have a situation, like this, right? That's DNE, or you have those asymptotes. These are DNE examples.
But that can only be for lim x to a, not like to the left or the right.
So limits from the right and the left generally like always exist, unless they're going to infinity or negative infinity, in which case like you can say they don't exist. But in general, if you're going from the right to the left, they should either be infinity, negative infinity, or some number. It's limits to a single point from both sides that genuinely do not exist, like in this situation, and this situation too. Okay. Limits analytically and limits to infinity. So there's these, really two steps. The easiest way to solve limits analytically is called direct substitution. That's when you do what? You just put it right in, right? And that's easy. Two is if you get what? If you get 0 over 0, what's that called? It's called indeterminate. In that case, what do? You factor. Okay? For limits to infinity.
What do you mean factor?
So we'll do an example problem.
Okay.
Factor and simplify, I think, is better. And then if it's to infinity, right, you look for like quote unquote biggest term, right? This is the order, the hierarchy, the order of domination, right? The biggest term. Okay, and we'll do example problems for all of these. So definition of continuity, there are 3 parts to the definition of continuity. The first one is that what? The first one is that the limit exists. That's the first one. Limit exists at this point. The second one is that the function is defined. And the third one is that the limit equals the output. Okay? That's it. So the limit needs to exist, the function needs to be defined, and then the limit needs to equal the output. And if all 3 of these are true, it's continuous. Okay. Turn the page over. Intermediate value theorem. So again, this is another good one for flashcard. The idea with the intermediate value theorem, again, is like if a function is continuous and you know that it starts here and ends here, and you know it's continuous, then it has to hit all the values, all the y values between these 2 y values. So the sentence that you need to know is that since function is continuous, and f of a equals some number and
now we got I don't know, it just came out in one piece. Bring it back, let's go.
Just.
Boys. Here we go.
Is it still recording? All right. We're still there.
We're live.
All right.
Let's go.
Okay.
So stupid.
It's all good. Always you begin again.
Yeah.
So, since the function is continuous and f of a is some number and f of b is this other number, there must be a c on the interval a, b, where f of c equals k, where k is between these 2 values. Okay, so again, like these like letters and like hash signs that you're seeing, that they're not. You don't write those. You replace those with numbers.
If we just understand the concept.
I want to see, like, the key parts are, I want to see that you say that it's continuous, and I want to see that you say that this is here and this is here, so we have to hit the number in between these 2, right? That's what I want to see. I want to see those key points, that it's continuous, that this output is this number and this output is this number, and therefore we have to hit the numbers in between. Like if you say it in slightly different wording, that's fine, but I want to see those points. Continuity, I want you to tell me what the first output is, the second output is, and then tell me your conclusion. Okay. Find the missing k was where you have a piecewise function like 2kx plus 3, and then maybe like 5x minus 1, and then they split off at 2. So this is for x less than or equal to 2, and this is for x greater than 2. And it's
this is the piecewise.
Yeah, it's like what k value makes this true, and so you plug in 2 to both and set equal. That's how you solve this. Again, we'll do an example problem of that. And then, okay, what we got down here? This is what we did last lesson. So this one, I took out this. There's no more equation of the tangent line. Okay. There is the formal definition of a derivative with a limit, which was from last class. The limit as h approaches 0 of f of x plus h minus f of x all over h, right? That's the limit definition. You know what, I'll give that to you guys. That'll be on the test. So you don't need to memorize that. I'll give you that. Okay? This is a given. But what you need to be able to do, and maybe we'll do an example right now, is you need to be able to find the derivative if you're given this. So as an example, and this is the same as this point, example would be if f of x equals x squared, how do you do this? You plug in x plus h into the x, so you get f of x plus h. That would be the same as x plus h squared, which is x squared plus 2xh plus h squared. Okay. And then we're going to plug that in. So we have x squared plus 2xh plus h squared minus f of x, which is just x squared, all over h. And then things cancel. So this x squared and this x squared will cancel. So you have 2xh plus h squared over h. The h's cancel here. And so we have 2x plus h. And we'll take the limit as h approaches 0. So that means we just plug in as 0 for h. So the answer is just 2x. Right? That's the derivative. And if I want the derivative at, let's say I want the derivative specifically at 3, I would just plug in a 3 into this.
Wouldn't it be 2x plus h squared?
No. So I'm going to go over this from the top. So this will be given to you at the top. Over here, you'll be given some function, and then you're basically filling in this piece of the puzzle.
So the answer is 2x plus h, not 2x.
The answer is 2x.
So it can't be.
No, I'll walk you through it. So f of x is just x squared. You see that? F of x is just x squared. F of x plus h you get by plugging in x plus h in for that x. So x plus h squared is x squared plus 2xh plus, it's be h squared.
Yeah.
Are you following me so far?
Yeah, I follow you.
Okay.
There has to be an h because they can't have a slope at a certain point.
Well, what happens is when we plug this in, the x squares cancel, so we end up with 2xh plus h squared over h, and these h's cancel, right? We're factoring out that h on top and canceling it out. And so what we end up with is the limit of h approaches 0 of 2x plus h, and what we do is direct substitution. We plug in the 0 for h, and all we have left over is 2x. That's why the derivative is 2x. Does that make sense? And I know, you can't. Yeah, you're right. You can't take the rate of change. You have to have 2 points to take the rate of change. You're right. And this is the way we get around that.
Got it.
Okay. So that's it in terms of of notes. If you want to keep following along, you can stay in here. If you want to go outside, you go outside. But I'm just going to do the whole practice test. Okay. So if you're kind of feeling lost, maybe you should stay here. if you want to give it a go outside.
Give it a go.
Okay, I'm gonna pause it just right now, just for this moment.
Mr. Kelly.
Give me a second.
Oh.
No, all right. Okay, so here we go with the questions. First one here is really straightforward. You really don't even need this first sentence here. It's just asking, what is the average rate of change over f over the closed interval of 0 to 10? So we want the average rate of change from here to here. If you remember, average rate of change is f of b minus f of a over b minus a, right? So we just need to plug in these values. My b value is 10, my a value is 0. F of b is given to me, it's just negative 20, and f of a is 5. So your answer would be negative 20 minus 5 over 10 minus 0. That's negative 25 over 10. That's the same as negative 5 over 2. So it's B. Okay? For 2. So 2 is just... 2 is asking you to write the function in limit notation. So it says, okay, if f of x is 3x squared plus 2x, then what's the derivative written in limit notation? So, I mean, first things first, it says h approaches 0, not x. So b and d we can eliminate because it says x approaches 0, it's h approaching 0. And then I have two options. It's either 3x squared plus 2x plus h, or 3x plus h squared plus 2x plus h. So when we fill in, again, the limit definition is limit h approaches 0 of f of x plus h minus f of x over h. When you find f of x plus h, that means plug in x plus h for all x. So what you would have is 3x plus h squared plus 2x
F of
plus
3x
h.
plus h squared, right?
Say it again.
Wouldn't it be f of 3x plus h squared? Or does that get rid of the x? Does that get rid of the f of x?
That gets rid of the, when we plug it in, that is when the f of x goes away, the f of goes away. So we end up with C for this one. Because this one is representing the x plus h is being plugged in for all the x's, whereas this one, it just like adds h at the end. It's the x plus h is plugged in. So the answer is C. Okay. All right, continuing on. All right, this is kind of where we left off. Use the limit definition to find the following. So this is this is last class. So again, limit definition, which I will give to you. So you don't need to memorize this. You'll be given this. Limit as h approaches 0 of f of x plus h minus f of x over h. This is what you're going to use. So f of x, I already know f of x. That's easy, right? That's just x squared plus 15x plus 14. And h is easy. The only thing that's hard here is f of x plus h. We need to find that. So let's go ahead and find that, f of x plus h. And that means, again, plug in x plus h for all the x's here. So it's going to be x plus h squared plus 15 times x plus h plus 14. Okay, we're going to simplify this. X plus h squared is x squared plus 2xh plus h squared plus 15x plus 15h plus 14. Okay, can we combine any like terms here? I don't see any like terms. This is kind of, we're going to leave this like this. So basically this whole thing is f of x plus h. Right, so now I have that. I have all three pieces of the puzzle. I can write it out. We'd have x squared plus 2xh plus h squared plus 15x plus 15h plus 14 all over h, and on top, minus x squared plus 15x plus 14.
Do we need to know the tangent line, the equation of tangent line?
Oh, no. See, you don't need to know. So here, things are going to cancel. So x squared cancels with the minus x squared, 15x cancels with the minus 15x here, and 14 cancels with the minus 14 here. So all I have left is 2xh, h squared, and 15h. Now the h's will cancel here and here, here and here. So we're left with 2x plus h plus 15. And we're taking the limit as h goes to 0. So this is just 2x plus 15. That's your derivative. So f prime of x equals 2x plus 15. If I want to find f prime of negative 7, all I'm going to do is plug in negative 7 into this. So I'd have 2 times negative 7 plus 15. That's 1. So that's your answer to B and your answer to A. And then don't worry about C. Okay? Nobody's really paying attention, but that's okay. Hopefully you're watching this video in the future.
What?
And it's like, it's Sunday night. And, you're probably stressed
probably
right
more
now.
like Saturday
You-
afternoon, as some people have stuff to do on Sunday. That would be more
Okay,
realistic.
Maybe you want to send me an email right now asking for another extension. Maybe that's what you're thinking. But you can do this. I believe in you in this moment. You can do this. All right, we're on number 4. Find the following limits. Show your reasoning analytically or graphically. Okay.
Direct substitution first.
Yeah, this is not too bad, this stuff. This is direct substitution, so that's the first thing you want to try. Just plug in a 2, right? So plug in a 2, you get 4 minus 2 plus 1. That's just 3. Easy peasy, right? Here, same thing. Plug in a 1. We're going to get 2 on top. We're going to get 1 on bottom, so it's just 2. Right, this was just 2. Easy. Plug in a 1. Same thing here. Nothing special. It's just square root of 9. It's just 3. So these are all straightforward. Yeah.
For the second one, would it be 3 on the top?
It would be 3. That was my bad. Sorry.
Oh, good.
Woo!
Is this thing on?
Yeah, we're live.
Oh, yeah.
We're live. There's a record of this correction. All right, continuing on. Now we got a limit to infinity. Remember, limit to infinity, you want to look at the terms. So my biggest term on top is 3x cubed. My biggest term on bottom is e dx. E dx beats 3x cubed, so this limit is 0. Remember, if the bottom wins, it's 0. If the top wins, it's infinity. And if it's a tie, you take the ratio of their coefficients. You'll see an example in that moment. So here, plug in a 2. We're going to get 4 minus 2 minus 2. We get 0. So this case, we do get 0 over 0, which is indeterminate. So this is where we need a factor. So let's factor that top. 2 numbers that multiply to negative 2 add to negative 1. That would be x minus 2 and x plus 1. And then x minus 2 on the bottom. These are going to cancel. So it's just going to be x. Now it's just a limit as x approaches 2 of x plus 1. And that's just 3.
They don't cancel.
The x minus 2
Oh,
is
yeah, you're
cancel.
right.
Yeah. We got another limit to infinity. This time it's a little more challenging because we've got like a root and we've got terms. But if I pick the biggest terms, our biggest term is going to be 10x squared on the bottom and then negative 64x to the 6th on top. But we're taking the cube root of it. So let me rewrite it over here. So it's a cube root of negative 64x to the 6th over 10x squared. If we were to simplify that top, the cube root of negative 64 is negative 4. So this is negative 4x, and then the cube root of x to the 6th is x squared. This is negative 4x squared over 10x squared. And so since we have a tie here, our limit is going to be negative 4 tenths or negative 2 fifths. So it's the same thing. So here, it's the same pattern. Like, look for the biggest term, top and bottom. We had to simplify with that radical here to get negative 4x squared. And then we took, because the degree was the same top and bottom, we took the ratio here. Yeah. Continuing on, we have another indeterminate here, right? Negative 3 squared minus 9 over negative 3 plus 3. This is going to be 0 over 0, or indeterminate. We're going to factor. We have a difference of squares on top, so it's going to be x plus 3, x minus 3. And on the bottom, we'll keep the x plus 3. These are going to cancel, so we just have x minus 3. And so the limit as x approaches negative 3, we just plug it in, and we get negative 6 is our answer. Okay. Another one here. They keep going. Negative 3 squared minus 9. That's 0 on top right now. How about the bottom? So negative 3 squared, that's 9. That's 18. 18 minus 21 plus 3. It's another 0 over 0. So we're going to have to factor it. Factors at the top are x plus 3 and x minus 3. Factors at the bottom are going to be x plus 3.
Wait, how do you find that?
Sorry?
Can you tell us how you found the factors at the bottom?
Okay, so the factors at the top is just a difference of squares, x plus 3, x minus 3. The factors at the bottom, you could do ACB method, you could do like the box method, but I kind of...
Isn't it just 3 and 4 then?
Well, it's not 3 and... Well, you would split it up into 3 and 4 if we were doing ACB. Let's just, you know what, I'll do ACB as a review down here. So we have 2x squared plus 7x plus 3. If we're doing ACB, we have two numbers that multiply to get 14, add to get 7, and those are going to be... no, sorry, 6, 6. And that would be 1 and 6.
So x plus 1.
That can't be right. That is right, yes. That is right, that is right. So this can be x, and this can be 6x plus 3. Sure, we'll do with that. And then this will be 2x squared plus x plus 6x plus 3. This doesn't look great because of the way we're going to factor. I'm actually going to switch these. So we're going to write it as 2x squared plus 6x plus x plus 3. This is better. Okay, then here we can take out a 2x out of the left. 2x, x plus 3. Yeah, there we go. Plus, and then this is fine as x plus 3 here. So our factors are 2x plus 1 and x plus 3. All right, so that's back up here. This would be a 2x plus 1. Anyway, these are going to cancel here. This is what I have left over. X minus 3 over 2x plus 1. And we're going to plug in a negative 3. We're going to get negative 6 over, what is that, negative 5. So it would be 6/5 would be your answer. Okay?
So what's the answer?
The answer is 6/5.
Oh.
So you factor, cancel, plug it back in again, you get 6/5. This one, so again, same thing, the biggest degree on the bottom and the biggest degree on the top. This one's like a little more challenging because it's not been multiplied out. If we were to multiply out the bottom, the biggest term would be negative 25x squared. You see that? We'd have to multiply it. That would be the biggest term. And on top, if we multiplied it out, we'd get 7x times 5x, so that'd be 35x cubed. And the cube beats the square, so this limit is just infinity. Okay, so here, again, it's not multiplied out. See how it's not multiplied out? So we have to do that ourselves. So 5x times negative 5x would be negative 25x squared, and 7x times 5x squared would be 35x cubed. I don't care about the other multiplication because those don't matter. It's only the biggest terms that matter.
So you were trying to trick us?
Well,
do more work?
That's what if you did more work, that's fine too, but this is kind of a shortcut. Okay, on 5, we're writing this in sigma notation. There's 1, 2, 3, 4, 5 terms, so that means in sigma notation, we're going to start at 5, at 1 rather, and we're going to go to 5. Okay, and what's happening each time? We go 8 to 5, that's plus 7, and plus 7 again. So it's always plus 7. Okay, so it's plus 7 each time.
So it's x plus 7?
So it's going to be...
I plus 7.
It is going to be 1 plus 7i.
Why do you need that 1?
Because for your first term, you want 8. So your first term would be plug a 1 in, you get 8. Then you plug a 2 in, you get 15. Then you plug a 3 in, you get 22. You plug a 4 in, you get 29. You plug a 5 in, you get 36. So that the 1 is there because your first term is 8. So to get 8, you have to have 1 plus 7i. So when you plug in, that's why the 1's there. Does that make some sense?
But that doesn't work then.
It does work. When I plug in a 1, I get 8. When I plug in a 2, I get 15. That's what you want. There's other ways to do it, but this is one way.
Oh, you're right.
Yeah. Okay. Alrighty. Continuing on. Is the function to the right continuous at x equals negative 3? Explain using the formal definition. You must list all 3 conditions. So let's go ahead and do like a checklist 1, 2, 3. So first thing first, does the limit exist? Yes, it does. So we can say limit as x approaches negative 3 of f of x. I don't know why I said limit. Limit f x equals negative 3, x approaches negative 3 of x exists, right? So that's checks number 1. 2. F of negative 3 is undefined. So that fails it. And then, right, the limit as x approaches negative 3 of f of x does not equal f of negative 3, so we fail this one too. So it is not continuous, and this is fine as an answer. Okay. For what value k in the function given below does the limit as x approaches 1 exist? So remember, the limit exists at a value, like the limit from the left needs to equal the limit from the right. So we are going to set both of these equal to each other at 1. Let's do that. So we're going to have negative 2 minus 7 equals negative 1 minus 2k. So that's negative 9. So this is just 8, negative 8 rather, equals negative 2k. So that means that k must equal 4. That's pretty easy, right? All you're doing here is saying the limit as x approaches 1 from the left needs to equal the limit as x approaches 1 to the right. And the way that we verify that is by setting these two sides of the function equal to each other at this cutoff point 1. And we just solve for k. Okay. 8. Sketch the graph of the function q for which limit q approaches 3 from the right equals 2 and 3 from the left is negative 2. So you can just draw an axis and sketch this. As we approach 3 from the right, it's 2. So it means, like, let's just call this 3. As I approach 3 from the right, it's 2. This is 2 right here. As I approach 3 from the left, it's negative 2. So it can do whatever I want over here, but down here, it's negative 2. That's it. We did it. And there's multiple different answers for this. As long as you show that from the right, it's approaching 2, and from the left, it's approaching negative 2, you're fine. Okay, we got some graphical limits here. This is very important. So be familiar with number 9. Definitely, I mean, be familiar with it all, but this is, you can expect a question very similar to this on the test. So negative 4 from the right. Here's negative 4. We're approaching it from the right. The limit's negative 1. Negative 4 from the left. Okay, so we're approaching negative 4. We're approaching from the left. It's at 1. So the limit of negative 4 overall is d and e because these do not match. The limit as x approaches 1. Again, we approach from the left, we approach from the right, it approaches the same point. Even though it doesn't exist here, it still counts. It's 4. Limit as x approaches 4 from the right. 4 from the right, we are going up to infinity. I would also accept d and e as an answer. The limit as x approaches 4 overall, also infinity, or you could say d and e is also fine here. If it's infinity, you can say d and e. Okay? Either one is fine. F of negative 4, so this is the output. The output at negative 4 is negative 1 because that's the filled in point. The output at 1 is an open hole, so this is undefined. And then f of 4, again, because it's a vertical asymptote, that's undefined. Okay? We got that? All right. A couple more pages, we're nearly done. All right. Given that f of x is root x plus 1, sketch the graph from 0 to 5. Cool. So this one, you can just, you could make a table if you want, and you don't have to get every point. So x and y, what's a good point? Let's plug in 0, right? Plug in 0, we're going to get 1. If we plug in a 1, we're going to get 2. 2 and 3 are kind of challenging because they're irrational numbers, but if I plug in a 4, root 4 plus 1 is a 3. So I can get a decent sketch of this. So we start at 1, then we're going to go to 2, and then at 4, I'm at 3, so 5, we'll call it roughly there. So this is fine. Something like this. Okay? It's going to kind of continue like that. Okay. Draw 5 left endpoint rectangles in the given interval. So left endpoint would be starting at 0, going up to the function right and down, up, right, down, up, right, down, up, right, down, up, right, down. Those are my 5 intervals. And then it says write sigma notation for the sum of the rectangles. So it's not even asking me to calculate them. It's just telling me to write the sigma notation. So because they're left endpoint, you're going to start at I equals 0. And we're going to go to n minus 1. So the number of rectangles n was 5, so n minus 1 would be 4. And then on the inside here, it's width times height. So my width for each one is 1. That's pretty, I'm just going to write that as a placeholder. They're each 1 wide. And then the height of them is f of 0, your starting value, plus that width, which is 1, times I. That's it. So really this could be simplified to just be f of I, but I'm writing this as like to make sure it makes sense. So again, this is the height here, and then this is the width. If it's left, it's 0 to n minus 1. If it's right, it's 1 to n. Okay? Proves that the function f of x is x squared minus 4x plus 2 intersects the x-axis on the interval 0 to 2 IBT. Okay, so this is a continuous function, right? Unless it tells me otherwise, or I have holes, like this is continuous. So I can start with saying, since f of x is continuous, always start with that. And then it's supposed to intersect the x-axis on 0 to 2, so it should be crossing from negative to positive. Let's find out what f of 0 is and f of 2. And f of 0 is 2, and f of 2 is what? So to plug a 2 in, we're going to get 4 minus 8 plus 2, it's negative 2. Okay, so this is going to work because f of 0 is 2 and f of 2 is negative 2. Does it have to be 0 between those two? Yes, it does, right? Because 0 is between 2 and negative 2. So since f of x is continuous and f of 0 is 2 and f of 2 is negative 2, there must be a c on 0, 2 such that f of c equals 0 because 0 is less than 2 but greater than negative 2. Okay? So we're talking about continuity. We're saying that, you know, one value is 2, one value is negative 2, so it must cross the x-axis. It must be 0 at some point. And that's it. Last two questions are trapezoid and Riemann sums. So this is kind of a review from your quiz. Use a trapezoidal rule to set up and compute an approximation for the area of g of x from 2 to 8 using 3 trapezoids of equal height. So from 2 to 8 will be from here to here. And it says only 3 trapezoids of equal height. So if it's only 3 trapezoids, that means they're going to have a width of 2, right? If you think about this, we're going from 8 to 2, so 8 minus 2 over 3. That's 6 over 3. So they have to have a width of 2. So this is one of my trapezoid, this is a trapezoid, and this is a trapezoid here. So we're going to have 1/2 b1 plus b2, so 1 plus 3 times 2 plus 1/2 2 plus 5 times 2 plus 1/2 5 plus 3 times 2, right? The height, quote unquote, of all of them are all 2, so those stay. And then what's changing is the b1 and b2. So 1 and 2, 2 and 5, 5 and 3. So these, actually the half and the 2 cancel on all of these. So we're just going to have 4 plus 7 plus 8. So that's 12 plus 7 is 19. Okay? All right, last question. Selected values are shown below. What's the left Riemann sum approximation of 0 to 7 using 5 subintervals indicated by the table? All right, so we're going 1, 2, 3, 4, 5. And it's a left Riemann, so we're going to take the left numbers here, and we're going to multiply by the width up top. Let's get those widths. So this is 1, this is 3, this is 1, this is 1, this is 1. That's the distance between each one. And let's set up the sum. So we're going to have 12 times 1, that's your first one, plus 17 times 3, that's your second one, plus 27 times 1, plus 29 times 1, plus 25 times 1. So what we end up is 12, 17 times 3, that's 30, and 21, that's 51, plus 27, plus 29, plus 25, all this together, was it 51, 60, 80, 105, 117, plus the 27, so 117 plus 27, that's 137, 144. I'm getting 144. Okay. That's it. That's the practice test. So I would go through this again, make sure you're clear on all the components. I think the most challenging part, because we did it last, is actually going to be these limit problems. So make sure you do this, do the delta on this, and come ask for help during class. You have 2 review periods, including today. So, all right.